Okay, everyone, welcome to Apache Flink 1.5 meetup today. So we're just kicking off first up to give you first an overview of what's been happening with the new latest release of 1.5. And Joe, our head of engineering at Viverica, will be talking you through that. So if you have any questions throughout the presentation, please place them in the Q&A and we'll answer them in the session following.
Okay, thanks, Kay. Welcome everyone to the 1.15 meetup. So I'm happy to give you a first glance at the highlights that the community has included. So let's have a look. But first about Viverica, we who are running this meetup. We are known as the original creators of Apache Flink, but we also do enterprise stream processing with our commercial products, and we are a subsidiary of Alibaba Group. So what's in 1.15? A lot of stuff has been added. We have been mainly focusing on 4 areas. So it was a lot of around ease of operation, unified stream and batch processing. And so when we had a look at the ease of operations, I will go a little bit later into the bold things with the eyes. So checkpoints and save point semantics, but there has also been a lot of stuff around application mode, reactive mode, adaptive scheduler, adaptive batch job scheduler, SQL version upgrades, but also continuing our story when it comes to unified stream and batch processing. Checkpoint handling for bounded or mixed jobs. So flip 147 is a term to everyone in the community, but also other things that we added there. Flink SQL. We did some cast type enhancement. So there has a lot of things have been grown over the years, let's put it that way. And the SQL, the people working on the SQL components did a great job on untangling things there and improving them. And we will also have a look on the Json Functions, one of the features that has been requested a lot by the community. What also went into this release was a lot around connectivity and extensibility. So connectors are really important. We've been working on the connector testing framework, but also cloud and interoperability. A lot of things have been added. Only a few are mentioned on this slide, but we also added the CSV format. Scala free Flink is also something that was raised some buzz within the community, and also small file compaction. So a lot of stuff, as you can see, that aligns with the story that we've been following over the last couple of releases. And now let's have a look at some of the features that have been added. So I selected them based on various reasons. But you can always have a look at the documentation and or ask us if you want to learn about other stuff. So checkpoint and save point semantics. Checkpoints and save points, they're really important when it comes to fault tolerance, and it's widely used. But it's also something that confuses our community a lot. So we get a lot of questions around that. And to be honest, it was not everything 100% clear. How are things done? Once again, things have grown a bit, and this time we clarified some of the aspects. So to sum that up, a general understanding of checkpoints and save points, what they mean. So checkpoints, they're owned and managed by Apache Flink, by the system. They are only used by one job, and they are cleaned up by Flink. So the ownership belongs to Apache Flink. Save points, they are owned by the user. They are never touched by Flink. They are self-contained, and they are immutable. So they can be shared by other jobs and applications. And so they are fully in the hand of the users, and users can do whatever they want with them. And that's like the main difference that we've been aiming for. But in the past, it turned out that there are like some special cases and some aspects of checkpoints that had benefits over save points. And so things have been used for use cases that were not intended. And so the community has been working on some of the problems. So for example, when restoring from a retained checkpoint, it might have ended up with unclear ownership, and people have could not rely on the rules that I've shown before. So we added claim and no claim mode. So when it comes to save points, when they had larger states, they turned out to be very slow. And what has been added was native save points, which in some cases are even incremental and making taking save points much faster. And then, as said, a lot of things, a lot of questions popped up in the community for that. We also did a significant documentation update and also clarified some of the states. So there has been some aspects of those features that were known that they are working, but they have not been documented, and the other way around. And so we used that to really narrow down some cases and clarify what does work and what not. So let's have a look at claim mode and no claim mode. With claim mode, Flink is claiming retained checkpoints or save points, native and canonical as well. I will go into that a little bit later, and might even eventually delete them. So once they fully retained recovered from a retained checkpoint, Flink says, well, I don't need it anymore, and then it might be deleted. One of the benefits of using that mode is also it can immediately continue with incremental checkpoints. This works for the retained checkpoints as well for save points that have been taken in the native format. And Flink is taking care of cleaning that up, deleting the snapshot at one point. No claim mode does a full checkpoint after restoring from one. And after that, the job is completely independent of the old checkpoint. So it does not delete it, it does not change it, it does not build on top of that. And those are essentially the two differences. Here's how you can use that from the CLI. And then looking at native checkpoints. So we intended to add native save points. That is wrong in the headline. We intended to add native save points, and but also if the state backend supports it. So for example, for RocksDB, they are also incremental, which also has some benefits when it comes to speed. And with that change, we also changed the guarantees for checkpoints. So this time's checkpoints is right. When it comes for upgrades for minor versions, for aligned checkpoints, upgrades for patch versions for aligned and unaligned checkpoints, but also for job upgrades. So in the documentation, there's a nice table overview that you can have a look at, and you will see how the behavior changes. So SQL version upgrades, that's also something that a lot of that has been urged by the communities. A lot of people have been looking forward to that. Disclaimer, we will only add this as an MVP, but it's already a great feature. So the goal was that the same query can remain up and running after an upgrade. For example, from 1.15 to 1.16. So starting with SQL jobs that have been started in 1.15, this will work. The basic design has already been introduced in 1.14, so there's some experience around that. The core of it are JSON plans, and as said, it's currently MVP. What was in scope? Restoring save points and executing pipelines. new Flink versions should be backward compatible. I added 2 stars because there might be cases where this is changed, but as we're generally speaking urging for making it easier to upgrade Flink versions, this should only be rarely the case. So not only to the users, but also to the contributors. Please be very careful with changing stuff there. What was out of scope? Schema and query evolution. So that's about SQL version upgrades. Then the SDK teams or the people, contributors working on connectors from various companies, they have been working a lot on moving to the new interfaces, especially when it comes to things. And one that we want to have a look at is the Elasticsearch thing. So it's based on a new unified sync interface. So we will see a lot of stuff moving in that direction also in the coming months in releases. The teams are working on making the experience for contributors and users better to connect to other systems. With the new Elasticsearch syncs, at least once semantics has been introduced. So there's a huge push with the new interfaces in that direction, and it's available for Elasticsearch 6 and 7. Yeah, that's one of the first steps and one of the pioneers connectors, but others will follow. So also in the AWS space, already a couple of connectors have been published based on new interfaces. How does that look? Maybe the most important thing is this delivery guarantee that now can be used. So you can set that to at least once as the guarantee. That's about the Elasticsearch thing. So now let's have a look at the Json functions. Once again, I think the contributors have been listening a lot to the community. So it was also one of the more requested features in the SQL space, and it adds functions to build, inspect, and extract JSON strings, and it, yeah, following the SQL standard. So we see some examples here. Yeah, you can use the ES JSON exists functions, JSON string. So you got like possibilities to create JSON strings, but also read it or yeah, create one from tables. That's all possible. Good. And that was like the quick rundown of the features that I've selected. Now let's have a look at what is the state of Apache Flink 1.15. So we got the RC0 out just this week. We've been working heavily on resolving all the blockers. That has been the case just recently, also thanks to the effort of all of the contributors. And now RC0 has created by the release managers. And we would like everyone who also is on that call and who's listening to this presentation to give it a try. We're heavily relying on the feedback of users that are running maybe production workloads on Flink that maybe have like a staging server, something that I can give on RC0 easily a try, so that we can learn from that, stabilize it, and once you will make it public available, that it has a certain degree of stability. So the votable RC1, which could be like the turn into the real release, that will be released once we got all issues resolved. So now a lot of tests are happening. Let's see what pops up. And then once we are quite certain and the community agrees that we're stable enough by voting on it, we will release it. And that's about it from my end. And I will now hand over to the AMA.
Thanks, Joe. There are already a couple of questions asked, so let me ask them to our guests, Matthias and Chesney right now. So the first question that was asked, how to manually store a value in a checkpoint or save point, and can that be retrieved during a restart? Chesney, could you perhaps answer that one?
Yeah, so the question is a bit unclear. If you want to modify a save point while the job is not running, then you want to take a look at the state processor API. If you want to do something where the job is running and you want to eject some state from the outside, then this is currently not possible. So state can only be modified from within a job.
Great. Thank you, Ajit. I hope that is clear enough. If not, please answer or post your follow-up question in there. Then there's another question from Brian. Does a checkpoint only save metadata or state information and not the data, while a save point is all of the above, kind of like a control plane versus control plane plus data plane? I think, Chesney, you're probably also best to answer that one.
Yeah, so if I remember correctly, the format of save point and checkpoints is generally the same. You have consists of some file that contains a bunch of pointers to files that are stored on disk somewhere, usually some durable file systems. So in that respect, they're the same. But the question maybe was targeting was this whole concept of save points being self-contained. And with that, we only mean that, so when you have a checkpoint, in particular incremental checkpoints, it can be that one checkpoint uses a pointer to a file of another checkpoint. And that's not the case for save points.
All right. That's great. Then, Kay, probably a question for you. If there are any plans for an on-site Flink Forward in Berlin this year?
Thanks, Martijn. So yes, we are looking into the possibilities of a European event and adjacent to the America schedule that we've released. Tickets have gone on sale and call for presentation in the last couple of weeks for a 1st to 3rd of August program. So we will be looking into just the plan of the landscape just reopening up with Corona, and then be making those announcements as soon as we know.
Right, that's great. Thank you for that. Then there's also a question. We're transitioning lots of custom Java workflows from batch, so the dataset API, to streaming data stream with bounded sources, and wondering if there anything about support/best practices for handling joins and sorting. I'm not sure if we have the experts on here right now to answer that question. But we do see this question being asked more in the community, and I think we are currently working or planning to go through a blog post to explain a bit more on how that could best be handled. So I would definitely keep my eye open for the blog posts that are being posted both on the Flink website as well as the Ververica website, so that we can hopefully answer and share some best practices in there as well. Then there is a question about local recovery. Started an experiment with a Flink pipeline running in Kubernetes, processing billions of Kafka events and using S3 for checkpoints. And the problems that's being faced is that whenever a pod is restarted or service is restarted, local recovery does not work. Everything has to be recovered from S3 before the job restarts. Besides the data transfer cost, there's a huge downtime. It was also tried with 115 snapshot, but it does not seem to work. Chesney, can you also answer that one?
Yeah, so what you want to look at is a new feature in 115 that, if I remember correctly, is opt-in, where you can specify a working directory for a Flink process. And if you set it up the right way, then what you can do is that when a pod restarts or is replaced, the new pod inherits the file system of the previous one and can just take over the work of the previous pod without having to redownload anything. So look for a working directory in the documentation and see if that can maybe solve your issue.
Great, thank you for that. Another question is what improvements have been done on the reactive mode and the adaptive scheduler? Matthias, perhaps you could answer that one.
You're muted.
Yes. Okay.
Yeah.
For the adaptive scheduler, we did two things. One is the exception history. So the exception history was extended, I guess, in 1.13 already for the default scheduler. And there was still something missing for the adaptive scheduler. So this is added now in 1.15. And the other thing is that task managers notify the job manager now when they decide to shut down. So there is a shorter amount of time until the job manager notices that the task manager is gone. Yeah, those are the two features we worked on for this release.
All right, that's great. And there is another related question. What has been done to the application mode? I think that's also one that you could probably answer best, Matthias.
Yes, for the application mode, there was a long-lasting bug or a problem in application mode when the job finished, but there was an error happening during cleanup. When the cluster then went down and restarted, we didn't know anymore what the state of the job was. So we started the job again, even though it was already finished. What we now did is introducing a new component, job result store, which can be configured in a way that it survives the Flink cluster shutdown. So that there we save the final result of the job, and it can be picked up again after a restart. And that enables us to see that, oh, the job finished already, so we don't have to restart it again. And solves the issue of starting a job that actually failed in cleanup.
That's great. Thank you for that. All right, another question that has been asked is why do the changes in 1.15 actually make operations easier? Chesney, can you answer that one?
Yeah, so we looked at a fair amount of the REST API in particular. And while it works for the most part quite fine if you use it manually, there are some there, when you're trying to build a system around Flink, you run into some really annoying edge cases. Just for example, let's say you have a system and now wants to cancel a job. So you send a job cancellation to Flink and it may succeed. But given that it's an external system, you have to account for certain edge cases like network failures. So you may want to retry that operation. But when you retry a cancellation in 1.14 and below, you got a not found error back, because we were only checking for running jobs when processing this cancellation. So this isn't a problem in that sense, but it's really unintuitive. So now that has been fixed, and if the job has been cancelled, we handle it transparently. Another big item was that they went in a similar vein, was related to save points. So if you wanted to trigger a save point and trigger exactly one save point, irrespective of if your message got lost or response got lost, then there wasn't really a way to do that. And this is now possible by specifying an ID in your request. Then you can retry as often as you want. If it arrives while the save point is already in progress, it's just going to be ignored. Or it's if the save point has already been finished. And then finally, what we looked at is publishing an open API spec for the REST API. So currently, the only way to interact with Flink's REST API is to either build something manually or to use the Flink client, which is quite limited. And we hope that this spec will allow users to generate clients in whatever language they want without having to do a lot of manual work. But this is still very, like, disclaimer, it's very experimental in this release at least.
All right, thank you for that. There was a question related to the operator. For that, I would actually will be addressed by Matthias when the AMA has concluded, and we will go a little bit more into the operator that's currently being worked on. There is one question in the Q&A: is SQL schema evolution next in the roadmap? I can actually answer that one. It's definitely high on the wish list. It's not. We don't have a concrete plan for Flink 1.16, but this is definitely a much requested feature, and we're working on that to hopefully address it in one of the upcoming releases. Then there is a question if we're planning to make any training courses on PyFlink for people who love Python, because there are currently only courses based on Scala and Java. Joe, could you answer that one?
Yeah, it's currently not planned, but maybe that's some good input. I already forwarded it to our training team. And yeah, maybe we ask in the community if there's like enough ask for it, then we might come up with such a training.
Great. That's really nice. I see that there was a follow-up question asked on the local recovery, that the documentation was followed, and to explain more on how a new pod would take over without data movements, that there's also an open issue about it. I don't know if Chesney, if you still can add something to that, or if it's better to actually move the questions to the user mailing list for this perspective. What would you say?
Yeah, it depends. Like I would have to read up again how specifically it would work and what the specifics are for Kubernetes. Admittedly, the documentation is quite generic and only really applies to standalone mode and doesn't have.
Okay, but perhaps it would be great.
Yeah, so there's an additional note in the Kubernetes resource providers page about it. So about creating a persistent volume that would be remounted. But I guess it assumes that like, for example, that the pods are all in the same data, so that you can actually have the same volume mounted.
Yeah, and it would definitely be good to, if we could have also this conversation on the user mailing list, because it gives us a little bit more time to check it from our end, and potentially also involve some of the other maintainers on Flink to get the best answer for your specific question. We would love to help on that. There are a couple of more questions left. One of them is probably best for Matthias. What's the plan for the per job mode? Can you share a bit more about that?
Yeah, for the job mode in Flink, and the community decided to deprecate it in 1.15. Our goal is to focus more on the application mode and add all the missing pieces in application mode, which are usually covered by the job mode right now. It would be good if anyone has still use cases where they think they use the job mode right now, but cannot switch to application mode, to share that in the mailing list. There's a mailing list thread for that, so that we can see whether there are already workarounds for that, or whether there's still some use case which we miss and where we should create a feature or issue for that to fix that.
All right, great. Then there is a question: why is Scala-free Flink such a big thing? Chesney, I think you can best answer this one.
Yeah. So Scala Free Flink was a very interesting project because it's one of those rare occasions where by cleaning up something in Flink, we could create value to users. So for the longest time, so Flink has certain components internally that use Scala and has APIs in Scala. And for the longest time, these has been linked such that they had to rely on the same Scala version, which presented problems for us because we could, for example, not just update our Akka dependency without dropping support for all the Scala versions. This has now been fixed. What does it benefit users? So one thing, for example, is that you can now, so Java users were also limited in the Scala version because the Java APIs also had a somewhat hidden dependency on the Scala APIs. So this meant that if you were writing an application in Java and you wanted to use some library that made use of Scala, then you always had to make sure that what you're using matches what Flink provides, which can be a problem. The second issue that or the second type of user where value I think is being added is users who write their applications in Scala but use the Java API, and they are now free to use whatever Scala version they want. So you can use older Scala versions if necessary, but also of course newer Scala versions without being restricted by what Flink does. And what we've now already seen even before the release, which was really exciting, is that we have external projects starting creating Scala APIs for Flink that users can rely on. So when users are no longer constrained in the development cycle of Flink when it comes to which Scala version is supported.
Awesome. Thank you very much. Then Joe, there's a great question for you. Is there a date for the 1.15 release?
As soon as possible. So as said, we're just created the RC0 and let's see what test feedback we get for that. Yeah, usually it takes like 1 or 2 more release candidates. So we're talking about maybe 1 or 2 weeks to get that out. That's the approximate time frame. But yeah, don't nail me down on that.
No, we'll hold you to this, Joe. No worries. All right. Then there is one more, or actually 2 more final questions, unless there are some more asked. So this is, I would say, last call for posting them. Question, if it's possible to store save points in a persistent DB or cache server such as Redis, and related to that, if it's possible to encrypt the save point. Chesney, could you answer both of them?
Yeah, so in regards to persistence DB and Redis, checkpoint and save points can be written to any location where Flink has a supported file system or there is a Hadoop file system for it. I'm not aware of a file system for either of them, but one would have to double check that. As for encryption, there is no general mechanism within Flink that allows the encryption of save points, but there may be certain file systems that do allow it. We would have to check the individual file systems.
All right, great. Thank you all for taking your time to answer the questions. I think they are much appreciated by those who are currently participating. And I think since there are no more questions, we can conclude the AMA part and move on to the next part on the Flink Kubernetes operator.
Thank you. Let me share my screen. Can you see my screen?
Yes.
Yep.
Okay, I'm supposed to share this one with the terminal. Can you see that?
Yeah, we see a terminal on the left and a Minikube on the right.
Perfect. Okay. Let's also share the presentation. Can you see this also?
Yes.
Sorry, my first time doing presentation in this form. So, hello everyone. I'd like to first thank to the meetup organizers for inviting me here today. Let me start by saying just a few words about my own background. My name is MEETUP, and I'm a software engineer at Apple. In the last recent years, I have specialized in distributed stream processing while working on different Flink-based distributions. And currently I'm working on a brand new addition to the Flink ecosystem, the Flink Kubernetes operator, which will be also the subject of my presentation today. I have prepared with a short demo for you, and there will be time, hopefully, for questions after my presentation too. Over the past several years, we have seen a number of initiations that aim to operationalize Flink applications on Kubernetes. Flink's native Kubernetes integration on its own cannot give an answer for complete lifecycle management, for example. And there are a few open source Flink operators available today. However, none of them are maintained under the umbrella of a neutral entity like Apache Software Foundation. They tend to lack wider community participation and often go stale as their maintainers shift focus. So with the Flink community, we decided to introduce a new Flink Kubernetes operator and make it an integral part of the Flink ecosystem. We have just submitted an improvement proposal for the operator earlier this year, and we already adding the finishing touches to the initial release. This project would not have been successful without the support from the Flink community itself. So I'd like to thank all the contributors who worked on this release for the countless hours they put into this project and turning it into a booming community effort. Let me start by going through the basics of the operator first, and let's see how it manages Flink applications on a Kubernetes cluster. What is the Flink operator? Well, in a nutshell, it's an extension to the Kubernetes API to configure and manage complex Flink deployments on behalf of a human operator. The operator can upgrade, suspend, resume, and delete Flink applications and perform save points automatically. The operator extends the Kubernetes API by defining so-called custom resources, which are essentially new object types that an API server understands. In our case, a Flink deployment custom resource can describe application and session clusters. The example to the right contains the specification for a typical Flink application in YAML format. Most Kubernetes objects include two important nested object fields, the spec and the status. Users need to provide all the characteristics they want the resources to have in the spec field. This is also called the desired state. The status field of the Flink deployment custom resource captures the actual state of the object, supplied and updated by the Flink operator. The status captures everything the operator needs to know about the Flink application to control its life cycle. For example, the status of the job manager deployment, the job status itself, and the reconciliation status. And don't worry if you don't know yet what these terms means. I will continue with explaining what reconciliation means in terms of Kubernetes. The Flink operator follows the Kubernetes principles, notably the control loop. Custom resources can be submitted and changed by the user on a Kubernetes cluster anytime. The operator continuously tracks change events related to the Flink deployment custom resource. And when the operator receives a new event, it will take actions to adjust the current state of the Kubernetes cluster as part of its reconciliation loop. It makes continuous adjustment to the current state until the current state becomes the desired state. All lifecycle management operations of Flink deployments are realized using this very simple principle in the operator. So let's see what happens under the hood during the initial loop when a new Flink deployment is submitted to the cluster. Users usually interact with the cluster using the Kubernetes command line tool, kubectl or kubectl. When a Flink deployment is submitted on the cluster, the operator will first create a deployment for the job manager and a few additional objects too. For example, services for internal and external communication, config maps with default Flink and log configurations. Then the job manager deployment spawns a replica set and pod for the job manager process. Once the job manager is running, it will create additional pods for task managers, depending on the Flink configuration. And finally, submit the job. And I'm going to pause here, and I'd like to show a quick demo that I prepared. Hopefully, you still see my screen. I have an empty MEETUP cluster on my machine, and I'm going to deploy the operator using Helm chart. Helm chart is the package manager for Kubernetes, and you can install the operator with a single command. It's a nice and convenient feature of the operator. We can do a quick sanity check on the operator logs to see if everything is running as expected. Once we have the operator running, we can submit our job. There are quite a few examples that we added to the GitHub repo that you can start with. I'm going to use this time the same example that you have seen on my slide, plus, and that also contains an ingress entry. Maybe I better should to show this to you. So, very basic Flink deployment containing the Flink runtime, some resource configuration for the job manager, the task manager, the actual artifact that we are going to submit, and a template that the operator uses to generate a fully qualified domain name for the application for the users to access it from the browser. So let me quickly submit it. So the operator receives this new custom resource event, and it will start creating the Kubernetes object. And if we would like to access it by the browser, we should check the ingress entries. And if we are lucky, they should show up running in a browser. As you can see, this is a very basic job running with Parallelism 2. If at some point we want to change the specification of our deployment, we can do this by editing the custom resource. So let me quickly do that. Let's change the parallelism to 4. And we apply it on the cluster. It will wipe out the cluster and restart it again. And this time, hopefully, we'll see a difference in the number of task managers created. And if we check the cluster again, it reveals that it is running now with parallelism 4. This is very simple. We can remove the Kubernetes deployment also using kube control. It should gracefully tear down the resources. Maybe we can have a look at the logs again, just to see how the recycle loops is being globbed on the cluster and how the graceful shutdown worked in our case when removing the Flink deployment. And finally, we can uninstall the operator again using Helm, and it will remove all the resources that we deployed. So that was the short demo that I wanted to share. After seeing the operator in action, let's pause for a second and have a look at the full picture of the architecture. Hopefully you can see it's quite a busy diagram, but I wanted to talk about it, a little bit. The Helm chart creates a deployment for the operator, several config maps with default configurations and a service object for the validating webhook. The Helm chart also deploys an important resource called CRD. This is the schema of the Flink deployment custom resource. And the operator is often deployed in a dedicated system namespace and controls one or more managed namespaces where the Flink deployments are actually being submitted to by the users using kubectl. And everything else on the lower part of the screen in the managed namespace are created dynamically by the operator during the life cycle of Flink applications. Let's discuss a little bit the lifecycle management. The core responsibility of the Flink operator is actually to manage the complete lifecycle of Flink deployment. We already seen how to create, delete, and upgrade jobs using kubectl, and let's also try to understand how does the operator perform stateful and stateless application upgrades, and how can users trigger save points themselves. So Flink jobs can be upgraded by simply submitting a new spec to the Kubernetes cluster, as we see on the demo, and the operator will detect the change and will suspend the job first, keeping the old state if instructed in a specification, and then it will try to restore the job using the new spec and the old state if it is available. And this happens automatically in a single operation. As users are also allowed to break up this joint operation into a separate suspend restore operation by controlling the job state manually. If users put suspended in as the desired state in the job spec, and the operator will pause the job only, and users can resume it by changing back the desired state to running. Users has full control on how the state should be managed with the operator when stopping and restoring stateful applications. It is controlled by the upgrade mode field. I forgot to put it on the slide. The upgrade mode can be stateless, last state, and save point. And I borrowed a table from the operator documentation that contains the comparison of the 3 upgrade modes. The requirements on the Flink configuration and their implications on the job state and the upgrade operations. The table also gives you some hints on when these upgrade modes are supposed to be used. So out of the 3, the stateless is the simplest. It has no requirement in the Flink configuration, and apart from no save point should be in progress, it can be performed on the cluster right away. The operator will try to shut down the cluster gracefully or delete it when the cancel operation hangs for some reason, and deploy the new job back again during the restore operation from empty state. It's good for prototyping, and even it can be used in production for stateless jobs. The last state is the most sophisticated upgrade mode. It requires checkpointing enabled, and also the Flink native integration HA should be enabled. So the operator is using the Flink native integration under the hood. So everything that applies there with respect to the configuration can be reused with the operator too. The upgrade operation can be performed anytime. It will simply delete the Flink deployment, keeping the HA data in the config maps, and restore the cluster from the config maps. And it is recommended, this upgrade mode is recommended for most stateful jobs in production. And there's a third one, the save point upgrade mode, that requires obviously a save point directory to be defined. And also it needs a healthy running job, because it will cancel the job with a save point and restore it from that save point. And it's good for migrating jobs between environment or forking your job during A/B testing. Apart from the automatic save point that we have seen in the upgrade mode, users are also allowed to trigger save points manually by defining a random nonce value in the save point trigger nonce field of the job specification. And it will simply create a backup of your application state onto a durable storage. And with that, we have arrived at the end of my presentation. Hopefully, all of you have at least basic understanding of the Flink Kubernetes operator, about the operator basics, what is a control loop, and how the operator handles the lifecycle management. I have put a few links where you can find additional content and support. We have the GitHub repo next to the Flink core repo. There we have put a complete documentation on the Apache site already. And if you have any questions like you would related to Flink, feel free to reach out to us on the mailing list. So thank you. I'm happy to take any questions. I'm going to stop sharing and try to answer your questions.
Perfect. Thank you so much. Yeah, there was a question asked if this operator is going to be officially maintained by the project for every release.
So from 1.14 release, we're trying to keep backward compatibility and support all the upcoming runtime releases. But if for some reason this backward compatibility cannot be kept, then obviously not. But at least 2-3 minor releases will be definitely supported.
All right, that's great. Yeah, and the second part of the question was for if there are any people from Ververica, if there's any level of support planned for this in Ververica platform. Well, I can answer that question. That's currently not planned, but of course we're keeping a close eye on everything that's happening and are definitely taking it into account for future decision making. So I don't think that there are any more questions. No. Okay, did I miss one? I don't think so, right? I had them all.
I think you got them all, yeah.
Awesome. Do you want to wrap it up?
One just popped up.
Ah. All right. So first question is, what are the next steps for the Kubernetes operator project?
Yeah, for short term, we are obviously trying to harden it a little bit based on user feedback that we receive on mailing lists. There are a few low-hanging fruits, like making the validation framework pluggable, the monitoring framework pluggable similarly to Flink, and provide an easy customization for the operator deployment. We are considering adding bot template functionality, or simply use customize, for example, for extension. Yeah, that is basically. And on long term, we are planning to support the auto-scaling functionality with standalone mode, but probably not in the 1.0 release.
All right, that's great. Another question being asked, with this operator, does it support no downtime deployments?
Hopefully, yes.
Exactly, that would be the ambition. And one more question is if the presentation you just showed us will be added to the GitHub repository.
Good question. I have to ask it internally if we can share it or not.
Yeah, it would be nice, or yeah, even if we cannot share everything, then we could also consider taking out some parts potentially and add them to the documentation website for the operator itself. I think there are some things in there already.
I will ask around internally. Thank you.
Yeah,
this is a good question.
That's great stuff. By the way, before I go to another question, I see loads of people in the chat applauding for great work and the cool stuff. So do take the credits into account and pass them on to everyone who has been contributing to this.
Exactly.
Then there is one more. Thanks for the great work on the Kubernetes operator. Can you say something about the maturity of the operator and the release plan? When will it be ready for production grade setups?
So we are at the initial release, and as I said, we are working on hardening and testing the operator, like load testing. And I think when with the 1.0 release, it should be mature enough to use it in production. And we are actively working on it. It's all Java based, and we have tons of Java experts in the Flink community, and quickly fix it if anything breaks.
Yeah, and I think also that if you are interested in actually trying it out, all that feedback is much appreciated, even if it's not in a production situation, but running it locally, running it on your dev or your test or your user acceptance environment, all those information and feedback from that is really much valuable. And I would definitely urge everyone who's interested in trying it out and relaying your feedback back to the community to make it better for everyone.
Absolutely.
All right, then I would say last call for the last questions. I think we've answered them all, unless there now pops up another last minute one. You never know. I don't see any yet. All right, okay, can I give the voice back to you?
Yeah, absolutely. Thank you, Martijn, and thank you all to speakers today, as well as the moderators, Joe, Matthias, Chesney, as well as everyone else that's joined the call and all your questions coming through. It's been really exciting reading through those and answering them live for you. If you did want to catch anything that you've missed today, the recording of the call has been live streamed to the Verica YouTube channel. So check that out and hope to see you all next time. So we have coming up for the next one, a webinar, which will do a deep dive that Joe will take you through for the Flink 1.5. So that is scheduled in the next couple of weeks. So the date of that one, 1 second. So the date of that one is in the next couple of weeks. I just can't seem to open anything else on my screen here. But if you check on the viverica.com/webinars, you'll be able to register for that one there.
It's on the 20th of April at the same time.
Perfect. Thanks a lot, Joe. Perfect. Great. Thanks for coming, everyone. Catch you next time.
Thank you. Bye-bye.
Thanks, bye.